Members, today we are back in chemistry, and our chemistry is mainly practical. So remember, practical, your teacher told you that it is subdivided into two. We have what we are calling the quantitative analysis as well as qualitative analysis. So today my idea is going to be on what we call qualitative analysis. Qualitative analysis, mainly we are investigating the presence of the ions of anionic what? Anionic salt. Our focus here is mainly on what we are calling the cations as well as anions. Now, when we are investigating cations and anions, we have to look at ionic salts, but you categorize ionic salts, those ones which are colored and those ones which are non-colored. So my focus today is on those ones which are non-colored. So our practical investigation is going to be on a certain non-colored cation, which we are going to discover together that this non-colored cation and an ion is of which salt. So we are looking at non-colored cation. Now, this one is going to give us the name of the salt which we are investigating. So as we are investigating, remember there are some materials which are how to use: the test tubes, the boiling tube, the litmus paper, the holder, the fire source, the soda water, and the reagents. Those reagents, of course, you have to know how to read them. Those teachers usually write there the formula of putting their name. So you have to know how to read the reagents and how to use the dropper. So dropper matters a lot because it is one which is going to give us our results as we are putting little and as we are putting what? Excess. So try to follow me up in this video, and then you remind yourself. So remember this number always, you need to follow up the test, then you record your observation, and then you record your conclusion or deduction. Remember, as in chemistry, as you are recording your observation, we mainly focus on the color, focus on the state, focus on the texture. Then if the smell is there, you also mention. If the sound is there, in the simple terms, in this chemistry, you have to apply all of the senses. Apply the sense of smelling, apply the sense of hearing, apply the sense of observation or seeing, now apply the sense of seeing. So when you look at our salt there, now I want you to look at our salt on the petri dish. Our salt on the petri dish, that is the salt. Now we are going to discover that first of all, our salt is white. Then secondly, our salt is in a solid state. Then there is one state which you are looking for, the texture. Now you are looking for the texture. Now the texture, how are you going to take it? That is by feeling the salt. So you have to feel the salt using your fingers or your skin. Now our salt there which we are dealing with, that one is crystalline. Therefore, when we are recording our observation, as you are telling the teacher, we are going to begin that number. At the beginning point, we are going to tell the teacher that it is a white crystalline solid. However, avoid putting a lot of grammatical words because the space is not enough which is given to you. So it is better to come and say white crystalline solid. Don't add there it is or a. That one is just a wastage of time. So the best recording would be white crystalline solid. As simple as that. Then when we come to our deduction now, because it is white, we are going to outline all the non-colored cations mainly. So we shall come and mention here our lead, mention our aluminium, our magnesium, our calcium, and so on, the non-colored ones. Then we can even add there ammonium cation. Then when we come the side of anions, since now sulfates are crystalline and nitrates are crystalline and chlorides, it is okay to put there. It's okay to put there sulfate, chloride, nitrate. Remember, when we are writing this number, we begin with many anions and many cations. But as you are moving downwards, we see the number is going to reduce slowly. Now, after looking at that point of the appearance of the salt, let us try to look at what we are calling now heating point. So now when we are going to heat, members, don't forget this one, that our boiling tube should be dry. So when you are going to heat, don't forget that our boiling tube should be dry. How do you dry it? You make sure after washing it, you go to the fireplace or the flame, and then you try to dry it out. Then after drying it, then you have to put, you can see me there drying the test tube. So you have to dry the test tube or the boiling tube. After drying properly, then we make sure that we go to the point where our sample is. Now the point of our sample, we are going to use the spatula end. So you can see we are drying now our test tube. Then now after drying our test tube, our boiling tube, then we use the spatula. Then now we add our sample. So you add such that all the solid moves down. So when you are adding, you follow what the teacher has told you. If the teacher say add it to spatula end is full, you put it to spatula end is full. When the teacher say one spatula end is full, you put that. So after doing that, you get the litmus paper. Then you dip it in distilled water. So you get a red litmus paper, you dip it, then you put it on the top of the boiling tube. Then secondly, you get a blue litmus paper still, then you dip it in distilled water. Then also you put on the top of your boiling tube. So after putting them there, then you go to the fireplace mainly. So as you are moving to our fireplace where is our Bunsen burner, if you are using a stove where there is a stove, remember that Bunsen burner you can use even a stove, or you can even use a charcoal stove. So it depends on what they have given you. What matters is the heating source. Then as you are heating a bit, you slant a bit to avoid burning your flames. Then when you are heating there, we are going to note what is happening inside the boiling tube. At one position at the bottom of the boiling tube. Then at the second position at the point near the top of the boiling tube. To discover, at the bottom we are discovering the color change which is occurring. Then around the top there we are discovering whether it is some is being given off. Then we are going to discover the change which occurred in our litmus. You can see that as we are beginning to heat our sample, now we are heating the one which was white, now it is turning reddish brown. You can see now it's turning reddish brown. Then as we are heating, we are seeing all our boiling tube inside now. The boiling tube is turning brown, and you can see even there is some fumes which are coming out which are brown. So as we are continuing heating, try to follow up the salt at the bottom of our salt which was white, at the bottom is now turning reddish brown. You can see even the whole boiling tube now. My boiling tube is turning brown, and my litmus papers, the blue one, is turning red. So this implies what? When I'm going to record there, I make sure that I record the fumes which are coming out, the brown fumes. Then I record the change of the salt here, which is turning reddish brown. Then I make sure that I also record the change on the litmus paper, as well as the colorless liquid which is coming out. Now from there, that after recording that, we have to make sure we record what is there at the beginning and what is there at the ending of our experiment. Now as we are recording, we are going now to record the observations as follows. At the point of heating, 1, a white crystalline solid melts into a reddish brown liquid. Then a reddish brown solid when hot and yellow when cold. Then 3, which you can give which was there, we can say that brown fumes are given off. Brown fumes given off. Then cracking sound. Then brown fumes. That turns damp litmus paper red. Damp litmus paper red. Those ones are going to be our observation. We have now how many observations? And then lastly, the residue turns yellow on cooling. The residue turns yellow on cooling. The residue turns yellow on cooling. Now, basing on the above observations, members, we can finally write our deductions by basing on each of the observations. First, we are going to say that nitrogen dioxide is produced. Nitrogen dioxide given off. Hence nitrates are present. Then 2, we are going to talk about water of crystallization, hence hydrated substance. Water of crystallization, hence hydrated substance. 3, we are going to talk about ready to oxide formed, hence ready to cations suspected. Ready to oxide formed, hence ready to cations suspected. Then still with cracking sound, then we can conclude that lead is ready to ions are present. Then because of melting, we still expect nitrates. Most nitrates are melting. Based on the brown fumes, we are saying nitrogen dioxide gas given off, hence nitrate present. Then liquid condensing at the cooler parts of the test, you will say water of crystallization, hence hydrated solid. Then 3, because of the reddish brown turning yellow, reddish brown when hot and yellow when cold, we can finally say that ready to oxide formed, hence ready to ions are present. The same with the cracking sound and the same with the melting. That is an evidence that nitrates are present. That is an evidence nitrates are present. Then members, from there we can go to the point of dissolving in water. When you are dissolving in water, you make sure you measure properly the amount of water, as the question is saying, or as the teacher has told you. When we are measuring our water, we measure our water using a measuring what? Using a measuring cylinder. So you measure properly the water, then now you get a clean boiling tube or test tube, then you dissolve there your salt. But you make sure that as you are dissolving your salt, you shake properly, such that the crystals or the powder try to do what? To dissolve. Here you are going to discover whether the salt is dissolving or not dissolving. Even at the point of dissolving can open up our mind that is it a nitrate, a chloride, a sulfate, a carbonate. Remember, carbonates do not dissolve completely. Remember, sulfates and chlorides of salts like calcium, they don't dissolve at all. So that one can, if it is a nitrate, all nitrates are soluble. So that is when now we can dissolve, then we discover that could it be a nitrate, a sulfate, what, depending on the solidity. So now you can see now we measure our water. After measuring our water using the measuring cylinder, then we are going to transfer the water into the boiling tube or the test tube, which is having our sample. So we have our test tube having our sample, then we are going to add there our water. So we added the water in the sample. Then as we are adding the water in the sample, what is the next step? We are going to shake. So there we add our water properly. So I put some care to avoid wetting. For example, your working place or even in the paper, now you shake properly. So as I'm shaking, I make sure that I observe whether the salt is dissolving or not dissolving. So you do thorough shaking Don't shake for 5 seconds or 1 minute and you run away. This is shake thoroughly as I'm shaking to discover whether the salt is dissolving. Now, you can see, so we continue shaking properly to see where it is. So when I'm shaking now, you can now see, members, that my salt has dissolved. So the salt has dissolved completely. So at that point, a teacher, you have to tell the teacher now. At that point, you have to tell the teacher, because he is waiting to see that now the white crystalline solid dissolves in water to form a colorless what? To form a colorless solution. You can see that one is going to earn your marks. Solution. Then the conclusion, which we are going to talk about the other side, our conclusion is going to be based on the salts which are soluble. We said nitrates are soluble. Nitrates are soluble. So there we say nitrate suspected. Then because of formation of a colorless solution, now we are going to bring back our cation there of red. Now don't bring all of the others which you mentioned at the beginning, calcium, magnesium, zinc, what? Because we have observed that when we are heating was acting as preliminary test there. We discovered that the salt may be containing lead. So because it's containing lead, now we have to maintain our lead as we are moving what? Downwards. So we are going to maintain our lead as we are moving downwards. So at that point, we are going to say lead 2 ions suspectedly present. Then we are going to maintain our nitrate. Our nitrate suspectedly present. Or our nitrate may be present or probably present. However, even if you don't put those words, you just put lead. That one is also considered 2 ions. We are going to divide into portions. Always they tell you to divide the salt into portions. Now I'm going to divide there into four portions. Now dividing into portions, it means you get clean test tube. Members, make sure the working apparatus you are using should be clean to avoid getting wrong results, and make sure you always use a little sample. When you use a lot, that one is a wastage and not give you the correct results. So always try to. Now after dividing the question, now our second part of the question, remember our first part of the question was saying appearance. That was our first part of the question, don't forget. Then our second part of the question was heating, don't forget that, members. Then our third part of the question, they are telling us to dissolve in water. And the water which they told us to dissolve in, it was 10 cubic centimeters. Then we have dissolved, then the man is telling us to divide into 4 portions. Which 4 portions we have already divided. Now for the first portion, the question is saying to the first portion add sodium hydroxide solution until in excess. That is the first part of our that is our first portion. That is our first portion. We are adding sodium hydroxide. Now when you are going to add your sodium hydroxide, make sure you use the dropper properly. So when you are going to use a dropper, you put a dropper and you press it there so that it sucks. So now we are adding our sodium hydroxide. Here we go. Now I got my sodium hydroxide. Then I get my dropper having it. Then I first put the first drop. You can see when I put the first drop, I see white precipitate coming on spot. Try to be observant. When I add more drops, the white precipitate is still there, but when I add more, it disappears. I want to tell the teacher that white precipitate soluble in excess sodium hydroxide to form a colorless what? Solution. White precipitate soluble in excess sodium hydroxide to form a colorless what? To form a colorless solution. Now, when we go to our conclusion now there, our deduction, it will know properly that one can be done by zinc, it can be done by lead, it can be done by what? Aluminium. However, I don't mention now the zinc and aluminium. Why am I leaving them? The ZAP issue. I don't bring here the ZAP. The teacher told you ZAP there. But it is dangerous now to put there zinc and aluminium. Why are we not putting here zinc and aluminium? You are going to discover that at the up there where we are coming from, this question, what you have recorded up, is going to guide you what you are recording down. Up there we have not recorded our last test. We have considered lead. Why are we considering lead? When we are heating, there was no evidence of zinc and aluminium. The evidence which was there, it was that the solid was reddish brown when hot. Then when it cooled, the solid turned what? The solid turned yellow. That was an evidence that one is lead. So when we come here, we are going to see that lead 2 ions suspected present. Lead 2 ions suspected present. As simple as that. Then now we continue with our tests. That is our test now. Remember we have said white precipitate, solid in excess, sodium hydroxide to form a colorless solution. Now the second test is saying to the second portion add excess aqueous ammonia. Now members, before you add even ammonia, you can see that the solution which we have formed by adding sodium hydroxide after the dissolving of the precipitate is resembling the other one where we have just added the water. Both of them are colorless solution. You can see if we are comparing the two. Both are color. This is colorless and then the other one is colorless. But the other one was for water, the other one was for sodium hydroxide. So you added the water, then you added the sodium hydroxide. Now you are going to colorless colorless. But remember this one, it was a white precipitate which dissolved to form a colorless solution. Now the second test is to the second portion we are adding aqueous ammonia. So there we go to our aqueous ammonia, then we are going to add there our aqueous ammonia. As we are going to add there, so now we get our reagent from the reagent bottle of ammonia, then we transfer drop here. So when you are transferring, try to watch the first drop. There we go. The first drop we are getting precipitate, white precipitate. Then we continue adding to look for the other issue of excess. Now when you add excess, white precipitate remains there. So continue adding to prove that the thing doesn't go away. So now we add more. We are adding more. So when you add more, you can see the thing persists there. This now implies that we are going to record our observation that white precipitate insoluble in excess ammonia. White precipitate insoluble in excess. White precipitate insoluble in excess ammonia. Don't forget that. That is one is going to be our observation. Now, after getting that observation, then we are going to conclude still. But here we are going to insist on lead still. So here shall insist on lead. So we shall say lead 2 ions. For the test, we are going to add potassium iodide. So this is my potassium iodide. So we are going to add potassium iodide. And this is my potassium iodide. You can see. So my third test, I'm going to add potassium iodide. That is my potassium iodide. Then I get my third portion. I put my drop and potassium iodide. Then I transfer. When I'm transferring, be careful. Don't just add anyhow. You can see I add my first drop. It brings yellow pipette. Add the second one. Add the third one. There we go. The oral solution now. My test solution. Remember that is the solution which we dissolved we ourselves and we divided. There we are getting now what we are calling a yellow precipitate. So when we are recording now, we can tell now the teacher that a yellow precipitate formed. Yellow precipitate formed. Don't even waste time putting a. Just say yellow precipitate formed. Yellow precipitate formed. You can see our yellow precipitate. Now that yellow precipitate being formed, it is only and only lead 2 ions which can form yellow precipitate when we have added potassium iodide. So that one is an evidence that we are sure it is ready to ion is present. So what do we do there? We confirm by saying that ready to ion is confirmed present. We actually even move at the end of the table where they put cation present, we put here ready to ions. Anywhere there is an ion already, we have our expectation that it may be nitrate, but we have not proved it. So it has first continue. Then our fourth test, they are telling us to add ready to nitrate. Adding ready to nitrate. So I go to my bottle now of ready to nitrate. I put it my dropper. I add. So when you are doing the work, avoid interchanging the droppers. So the drop of ready to nitrate, they add the first drop, no observation. Add the second one, no observation. Add the third one, no observation. If I shake, nothing occur. So you can see that what have I added? I've added ready to nitrate. It means what am I going to conclude? I'm going to tell the teacher the solution remains colorless. The solution remains colorless. That is what I'm going to record. The solution remains colorless. Then now that one means, because ready to nitrate always forms white precipitate if sulfate and chloride are present. But now I'm adding the things remaining unchanged. So it means in my conclusion I'm going to tell the teacher that sulfate and chloride are absent. Sulfate and chloride are absent. Then I put there nitrate present. So sulfate, nitrate, we are saying sulfate, chloride, and carbonate absent. Because the carbonate is already, if the carbonates were present, our salt would be powdered. That was the first preliminary test for carbonates. If it was a carbonate, it would be powdered. We discovered at the beginning it was crystalline. Being crystalline, we expect sulfate, chloride, and nitrate. Then we are coming at this point, we are seeing we are adding ready to nitrate, which is about to show us sulfate and chloride. Ready to nitrate is saying it is not there. If it was there, it would change to white precipitate. So now we come and say sulfate and chloride are absent. Then we say nitrates are present. Then we continue to confirm it more, whether the sulfate and the chloride are absent by adding barium nitrate and nitric acid. We can even add barium chloride and hydrochloric acid. There we go. I go to my barium nitrate. Now I suck barium nitrate reagent. Now I'm adding to my test solution. Remember, those test solutions are those on which we divided. You can now see that no observable change. No observable change. Now remember, as you have added one test, remember we are divided into 4. By now we are ready to call out that one barium nitrate. So now I have added another portion. That is the 50th portion. That is 50 portion. Now we add the barium nitrate, no observable change with nitric acid. That one, what are we going to record? We are just going to record that sulfate absent. Sulfate confirmed absent. There we go. We can now still stand on our nitrate. Sulfate absent. Nitrate present. Now this implies what? We are going to apply what we call elimination method. We are going to apply elimination method to reduce the nitrate. Since the salt gave us brown fumes at the beginning there, since the salt gave us brown fumes as we are heating, now where there is an ion present, we are going to put there nitrate. Where there is an ion present, we are going to put nitrate. Where are we putting nitrate? We have checked for the sulfate and the chloride, they are not there. Yet at the heating there, we got brown fumes, which can only be given out by what? By nitrate. So we come and say nitrate present down there. Where they are putting, we are going to start the ending of the question paper. We are putting there the cation present and an ion what? An ion present. Then our salt now, we can say that our salt was ready to nitrate. That is our salt. Now, to wrap up all the tests we have done, you can see that was the point of dissolving our colorless liquid when we added the water. So that is when we dissolve it in water. Then the second one, then we added sodium hydroxide, where we formed white princewood soluble form, colorless solution. Then we go to the third test. The third test, that one is adding aqueous ammonia. So we are seeing white princewood insoluble. White princewood insoluble. That is white princewood insoluble. White princewood insoluble. White princewood insoluble. Then we go to the test of adding potassium iodide. That is a yellow precipitate, which is a confounded test for lead. We have been expecting lead throughout, so that is confounded test. Then we go to the fifth portion where we have added radium nitrate, no observable change, the solution remained colorless. Then we go to our last test, that was adding barium nitrate and nitric acid, no observable change still, and our conclusion was ready to ion is confirmed what? Ready to ion is confirmed present. Members, when you are recording, try to follow up the question from top to the bottom. What you have not recorded up, you don't record it down. You can discover that our salt there, it was on the zap. Even though it was on the zap, but mere heating at the point top there, we removed the zinc and lead. We removed the zinc and aluminium. Because the salt was turning, it was white, then it was turning to reddish brown when it was hot, and it was turning yellow when it was cold. So we had to eliminate the aluminium and zinc, and we continue with our lead downwards. So don't say teacher told me everywhere I have to do zinc, aluminium, lead, and so on. It depends on the tests which you are getting up, which will guide you on